This is our fifth and final episode of our Marine Safety and Search and Rescue Exhibit Tours series. In our last episode, we explored a variety of marine safety artifacts from the Maritime Heritage Center. The artifacts we discussed came from numerous different countries and circulated across centuries. In this episode, I'd like to explore our artifacts with a more specific focus in mind. This episode is all about marine navigation, arguably one of the most important aspects of marine safety. Marine navigation has been a risky business since the dawn of boating. From the voyage of Charles Darwin to the sinking of the Titanic, navigating the seas unprepared can and will cause you trouble. It's no wonder then that there exist countless methods and contraptions which seek to aid in marine navigation. In this video, I'd like to focus on a handful of manual navigation and position finding tools before finishing off with a small section on the utility of radio position finding. I hope you enjoy. First things first, we have the venerable marine sextant, an analog navigation device which has been used since the 1700s. When held vertically, a sextant can be used to measure between an identifiable horizon line and a given celestial object, typically the sun or the moon. The sextant produces the angle in degrees, minutes, and seconds, which can be used to calculate longitude and latitude. The measurements of celestial objects can be used by the operator to determine their current position on a map. From there, the operator can use this information to ensure their vessel is on its intended course or make adjustments to readjust back to that course heading. Charting using stars and heavenly bodies has been a universal form of navigation since even before the first transatlantic voyage, and the sextant is only one among many devices suited for this unique purpose. Next, we have the telescopic cousin of the sextant, designed for a more specific role, the alidade. It is used to identify a vessel's bearing, which essentially means the degree of a position relative to the present heading of a vessel. For example, a 90-degree bearing off of a vessel headed due north would correlate exactly with due east. Used in conjunction with a sextant, the operator can determine both longitude and latitude, as well as the bearing of the celestial objects that they were observing to acquire those measurements. This is our final section of our final episode on marine safety and search and rescue. And so, why not have a little fun, shall we? Do you want to learn radio direction finding from a 1970s radio manual? Because I do. This is the MR1010 model radio direction finder, first circulated in 1975. The principle of radio direction finding isn't too dissimilar between the analog technologies of the sextant or the alidade and the electronic systems of our radio direction finder, except where a sextant identifies the operator's position by their relation to celestial bodies or notable landmarks, the radio direction finder does so by the relative position of identifiable radio signals. So, let's go step by step. The first thing you have to understand is the function of the antenna system. The antenna inside the radio finder housing is very directional. If you point either end of the antenna at a radio signal, it will pick up very little signal from that station. These are called the null points. Whereas if you point either side at a radio station, it will pick up a much stronger signal from that station. When you tune into a radio station, you will find that there are two null points in a 360-degree rotation of the antenna. These two null points are when either end of the antenna is pointed in the direction of that identified radio signal. Aligning the compass on the housing of the radio finder will give you your bearing relative to that radio signal. So, say we've aligned our compass and we've identified a signal. We'll say the signal is coming from Bamfield, and we'll say that our relative bearing is 75 degrees. By plotting a line through the station, we only have one line. Somewhere on this line is our position. By repeating this process, we'll have a second line. We'll say this signal is coming from Tofino at a 330 degree bearing. With this second line, we now have an intersection point. The intersection point where these two lines converge is our position, though only roughly. 2 lines are technically all you need, but 3 lines are standard for best accuracy, as they create a triangle cross-section showing an area where you could be rather than a specific point which is much less reliable. This is also why the process is called triangulation. This concludes our exhibit tour series on marine safety and search and rescue. I hope you learned something. And if you find any of the contents of these videos interesting, I encourage you to come check out the Maritime Heritage Center for yourself and show you there's more to look at than there is in these videos. You can find us at 621 Island Highway. We're near the pier. Thanks again for watching, and I hope you enjoyed. Till next time.